Hello, good afternoon everyone, most especially for my teacher, Sir Jake Pomperada, and as well as my classmate. In today's video, I'm going to present or report my activity 3 in our subject Software Engineering and Matrix 2024. So the title of my report is all about the matrix operation. Without a further ado, let's go to the next slide. So we have here the topic outline. We have the introduction of the matrix operation. We also have the brief history of it and importance of matrix operation in software engineering. We also have the applications of matrix operation in software development, and last but not the least is the conclusion. So let's go now to the introduction. So matrix operation are fundamental mathematical operations performed on matrices, so which are arrays of numbers. So these operations include the basic addition, the subtraction, the multiplication, and various transformations which are related to the topic. Matrices plays a crucial role in various fields such as linear algebra, computer science, physics, and last but not the least is the engineering. Okay? So understanding matrix operations is essential for solving systems of linear equations. So this is used to solve problems, representing transformation and handling data in various applications. So that's the introduction of the matrix operation. So we go now to the next slide. We have here the brief history. So when did it started? So here, it started in the year 1850s to 1860s, so one decade. So Sir William Rowan Hamilton introduces the concept of matrices. So he's the founder. In the early 20th century or 1900s, David Hilbert and Ernst Zermelo independently contribute to matrix mechanics. And in 1925, John von Neumann establishes the mathematical framework for quantum mechanics using matrices. Okay? So next, so we are now in the mid 20th century or 1950s. So matrices gained prominence in various scientific and engineering disciplines. So especially with the advent of computers. So in the year 1960s, so development of numerical methods for metric computations such as Gaussian elimination and LU decomposition. So further advances the practical applications of the matrix operation. And now on the present, matrices are integral to fields like linear algebra, computer science, physics, and data science. So it plays a crucial role in solving equations, representing transformations, and analyzing large data set. Okay? So same with our last subject, the big data or the data science. So it is used in machine learning. Okay? So next slide. So the importance of matrix operation in software engineering. Okay? Matrix operations hold significant importance in software engineering for various reasons. We have here the graphics and computer vision. So matrices are crucial for representing and manipulating 2D and 3D graphics transformation. So in computer vision, matrices are used for image processing tasks like edge detection, image filtering, and object recognition. So next is the linear algebra in algorithms. So many algorithms in software engineering, such as those used in machine learning and numerical analysis, heavily rely on linear algebra operations involving matrices. Matrix multiplication, inversion, and decomposition plays essential roles in optimizing and solving computational problems. So we also have here the data transformation and analysis. So matrices are employed to represent and manipulate data sets efficiently. So operations like matrix multiplications are fundamental in data transformations and analysis, particularly in fields such as data science and statistics. So we also have here the graph theory and networks. So matrices are used to represent graphs and networks in computer science. Adjacency matrices and others graph-related operations are essential for modeling relationship and connection in various applications, including social networks and routing algorithms. Okay, next. We also have the simulation and modeling. Matrices are used to model and simulate complex systems in software engineering. So, application range from simulating physical processes to modeling financial systems, and matrices help represent the relationship between different variables in these simulations. Next is computer graphics and animation. So matrices plays a crucial role in computer graphics and animation, where they are used to represent transformations, rotation, scaling, and translation. So this is fundamental for creating realistic and dynamic visual effects in applications and games. And last but not the least, the optimization and solving systems of equations. Matrix operations are vital in solving systems of linear equations, which frequently arise in optimization problems. This is applicable in various fields, including operations research, research allocation, and algorithm optimization. So next is we are now on the applications of matrix operations in software development. So number one, graphics and multimedia processing. So when you render videos or any type of animation, you are using matrix operation. So matrices are extensively used in computer graphics for number one, transformations, image processing, and rendering. So operations like matrix multiplication helps manipulative pixel data and achieve visual effects. In multimedia applications, so matrices are employed for tasks like video compression and decomposition or decompression. So machine learning and data science, we also apply the matrix operation on that kind of field. So matrices plays a central role in machine learning algorithms. So they are used to represent data sets, define mathematical models, and perform operations like matrix operation and perform operations like matrix multiplication during the training and inference phases. Matrix factorization techniques are common in collaborative filtering and recommendation systems. We also have the 3D graphics in game development. So in game development, matrices are crucial for representing transformations in 3D space. So they are used for transformation such as number one, translation, rotation, and scaling. So enabling realistic movement and interaction within a virtual environment. We also have here the signal processing. So matrices are employed in signal processing applications such as audio and image processing. So techniques like the discrete Fourier transform (DFT) involves matrix operations for analyzing and manipulating signals. Okay? So let's go now to the next applications of software maintenance in software development. So networks and routing algorithms. So matrices are used to represent and analyze network structures. Adjacency matrices and other graph-related matrices are employed in network algorithms to optimize routing, identify connectivity, and solve problems related to network flow. So optimization and simulation, so matrix operations are essential in optimization algorithms where they are used to represent and solve system of linear equations. Simulation software utilizes matrices to model and simulate dynamic systems, enabling developers to analyze and optimize complex scenarios. So next is the database systems. Matrices find application in relational database system. Okay, they are used to represent relationship between indices and perform operations like joins and projection in querying databases. So matrix operations contribute to optimizing database queries for efficiency. We also have cryptographic algorithm. So matrices are employed in cryptographic algorithms for data encryptions and decryptions. So linear algebraic operations such as matrix multiplications are used in certain encryption techniques to secure communication and protect sensitive information. So we also have the finite element analysis of if FEA. So in engineering software, FEA simulations are used matrices to represent and solve systems for equations describing the behavior of physical structure. Matrices help analyze stress, strain, and deformation in complex structures. Okay? So, at the last, the conclusion, so matrix operations are indispensable in software development, so serving critical roles in graphics, machine learning, game development, and signal processing. So network algorithms, optimization, simulation, database system, cryptography, and augmented virtual reality. So their versatility empowers developers to model complex scenarios, optimize algorithms, and create immersive experiences. A solid understanding of matrix operation remains a fundamental skill, driving innovation and efficiency in diverse software applications. Okay, so that's all of my report. I hope you learned something about matrix operation. So if you have any questions or suggestion, you can just comment on the box down below. Okay, so thank you so much for watching. Bye bye.